Okay, looks like we got a quorum. Welcome to Drake's Lounge, October 2024. The journal will be out. I'm still waiting for one article, and then we'll put it up on the server and send you out a notice. So hopefully, looking Wednesday, Thursday for the journal. So you should get an announcement with a link. And if somebody can't pick up the link works, and I'm seeing a lot of people having trouble accessing the link, and it's usually on their side. So if you can't get it because the link doesn't work for you, send me an email. I'll just send you a PDF directly. That's usually about 3 or 4 people out of the 600 I send it to has that problem. But not a problem. Just send me the email and I'll get you a copy. Start looking for announcements for the Western Conference. It's going to be at the VLA. Look around March 10th. Still working on the date. And we'll start getting announcements out for that right now. So if you guys never been to the VLA, that's in Socorro, New Mexico. And we usually stay at the Socorro, have the meetings at the Socorro meeting rooms. And then we take a day out and we travel to the VLA site and get a tour of that. So that's usually what the method is. Start thinking about some papers. Cap is the coordinator, and Wayne McCain. They are starting to look for papers, presentations, papers, whatever you want to work out with them, and we'll get started on that. Also on Eastern Conference, Marcus Fisher, your illustrious VP, is running that. He's also combined that with the Radio Jove team. Way back when, I don't remember the last time they had a joint Sarah Radio Jove meeting, but it's been quite a few years, but they're going to have another one here this next year. So we'll have a bunch of the Radio Jove guys in our meeting and we'll have joint presentations. So that's starting to be worked out now, and that'll be in sometime, I believe, in August next year for the Eastern Conference, and that will be at Green Bank. Okay. First to start, Alex has got a presentation followed by Jameson. Go ahead, Alex.
Okay, good afternoon. Let me share the screen with you. We up online?
Yeah, you're good.
Okay. I wanted to give you an overview of the status of this Project H-Line 3D that I've been working on with Jameson for the past several months. The goal of this was to provide an easy to construct antenna and also some software which didn't require a whole lot of technical expertise to understand. And I think this has met the goal. And I have uploaded a lot of files on GitHub. You can find it there, or now you could use any of 3 search engines and just search for H-Line 3D and it comes up. And so the idea is this Yagi, it's easy to build. You can build it with hand tools, except maybe an electric drill. The software produces files that are compatible with this Renier software, which is absolutely phenomenal. It's just fun to use. The information is really interesting. So let's see if I can do this. Hello. So this is the hardware. This is the latest version of this disk Yagi, and there's some major changes over what you may have seen before, in that the first 3 elements, the reflector feed and first director, have aluminum space between them, and they are all electrically tied together. The backbone of this is no longer a stainless steel rod. Not that it's better, but it's lighter, and that allows you to use a $25 tripod to hold the thing because it only weighs a few ounces. And the rest of the spacers are non-metallic; they're PICs, and this works really well. This is on the high point at the deck 20, the bright spot of the Milky Way. I'm getting about 1.45 dB over cold sky. Pretty good signal and noise. And it's, like I said, it's fairly easy to build. Then the software. Okay, the software is a derivative of some that has been used for a long time. SDR Sharp with Daniel Kaminsky's IF average has been around for a while, and his software can be set up to automatically record a data set, text file data set, columns of frequency and amplitude. Jameson has written some software to pull in a whole subdirectory of these files and process them as a group. What it does, it brings in all the data files, and these displays are also the graphics files that the software can show. So this is actually data using the Linear and 2D software. So it brings in a whole set of data. You can see the original data. It'll compensate for the drift. An area is selected which is not influenced by the hydrogen. And first it shows the drift over the entire 200 or 300 data point set, what the drift is over time, and it compensates for that. It subtracts them out. It does a power subtraction and it normalizes everything, converts the amplitude to dB reference to cold sky, and produces some really fun graphics. They're really interesting. And it's more than just fun in that there's a lot of information on a beginner's level that people can understand from this. You can see the LSR curve. I overlaid this with a line, but you can see the background shape, and you can get an idea of how every 12 hours, the Earth rotates around and your antenna is pointing towards or away from Earth's rotation of 40 kilometers a second, at least on the equator. And it produces some very nice graphics, and you could see the various peaks corresponding to different levels of the Milky Way. And this is part of the Cicera plot, and there's good correlation. This really works very well. And so you can get an idea of the red and blue shifts as you're going across here. So this is a lot of information for like a high school or undergrad student to take in, but it's there and it's available. This is what I've uploaded to the repository. The first couple are related to a detailed fabrication of the antenna, step-by-step processes of installing the software and using the graphics, installing the software for the SDR and IF average, and then another one for the graphics processing. Also include a little Excel template, which will do the same thing to one set of data. It will normalize it you specify a range, it'll normalize that to 0 and convert to dB reference to cold sky. I have the document which documents the past 10 months of this Yagi project, another one which is an expanded subset on NEC analysis of the antenna, and I also converted my Eastern Conference that I presented 3 years ago on a PDF. And so this is Jerry Taylor sent me this morning. So people are actually being able to use it. It works. So these are files from all of the files that Ridian will produce. And the hardware has been modeled, it's validated, tested, it works. And the software, I think the key here is simplicity. People can understand what you're seeing here. And it's not an advanced level, but for a high school student science project or something of that level, it's, I think, highly effective. I'm going to pass on this. If there are any questions, then I'll turn it over to Jameson. Mr. Adcock.
Hey, so I don't necessarily have a presentation to give other than I have been working with Alex on this for a while, and I really I've learned a lot. I didn't know decibels and doorbells when I got started, but wanted to do a Java program that kind of did the stuff that I was doing in C. When I first got started and didn't know what I was doing, I knew there was a background drift and I wrote some code to correct for that. So it was a lot of fun working with Alex on this, especially the graphing in Linear is, for lack of a better word, it's beautiful. Because I had been playing with Excel and I thought those graphs looked kind of cool despite some of Microsoft's limitations. But Linear for an open source project is absolutely spectacular. The software, we're going to keep making some updates and modifications to it. The initial version that went out, we had the right ascension stuff disabled because we thought there was a bug that I think we've tracked down. So that's enabled. We'll be able to do cool things like graph things by frequency, or you can change that to velocity based on the red shifts and blue shifts. You can determine just how fast different parts of the galaxy are moving. So that's where we're going with that. If you have bug requests, please, if you find a bug or a feature request that you have, just please let one of us know. And we're just going to keep working on it and adding features as we go.
Some overall questions the basic spectral processing, is it FFT or scanning or an analog filter bank? Just what is
This uses an SDR, software defined radio. And so within itself is doing conversion to real and imaginary components. And so these are FFTs.
How wide a band?
About 1.4 megahertz. I mean, it's variable, but it's kind of default sort of towards H line. I use 512 channels. The software runs, it may go beyond it, but typically 250 to 1024 is about the right number. I like 512, and it works with that. So all of these IF average files are columns of frequency and the corresponding amplitude, and then it's converted to power and normalized. I'm still not sure what causes all this drift, but it is disruptive to creating a nice flat background. So we smooth the background out and display it. And I think one of the key features is this linear graphics, in that for a younger person, it's reward for putting all this stuff together to getting a really fun plot that you can show people.
The hardware side, your system temperature must be of the order of 100 Kelvin. Is that correct?
I don't know. I mean, Sander, I haven't evaluated this for the noise temperature. It probably is in that range. I was trying to balance a lot of things. One of the things was to create an antenna that looks cool. The thing looks like a ray gun and something that could be put together. The initial ones I built in my machine shop. I have a metal leva bandsaw, a mill. It was a work-intensive effort to build these things. Jameson has one. There's 6 or 7 that have been fielded, but it's not something any person could do. And so the process over the past 3 or 4 months was to try to rebuild this, repackage this in a simple form, and it only weighs a few ounces, and you can install it on a $25 photo mount, and it won't tip over. And so it's a lot of balance. Nothing is optimized. The optimization was putting together something inexpensive, something tested, lightweight, and with some nice software.
Sure. Excellent putting all that together. Do you have any idea what the beam width of the antenna is?
About 30 degrees.
Okay. And for the first amplifier, what do you use?
It's a classic no electric Sawbird LNA H1 LNA.
All right. Very good.
Anyone else?
Alex, are you doing in the post-processing any correction of the local standard of rest?
No. In fact, I actually don't want to do that at this point, Wolfgang, because this is a learning opportunity. To see this curve, I think, is good. At this point, I want people to understand this thing rather than correct it. I want them to see all this. I think there's a lot of useful information that can be done here. Like I said, this isn't scientific level as you and many people are doing in, a more research environment. But I think as a first tick introduction to radio astronomy, there's a huge amount of knowledge that can be learned in this.
Yeah, the caveat, if you do some looking at the rotation curve or something like that, you can't do without a correction, because otherwise you're getting, strange results. Also, people have to be aware that if they repeat the experiment at a different point in time, they'll get a different result as far as velocities is concerned because of the different VLSR corrections.
But that's all useful learning. That's all useful learning for someone, rather than erasing it out and giving it a flat line. Let them learn some of this stuff. I mean, maybe later on there could be a higher level, like an intermediate level, but for a baseline, this seems like a good way to present the material.
Yeah, I think we've talked about some features like, correcting for that. And we can always create more graphs, like create a graph that has, that wobble removed. But I sort of like seeing it because I can really see just how much the Earth adds to the red shifts and blue shifts of the data that you get.
Yeah, if you want to correct it, you need to know where you are pointing.
Yeah.
So that has to be part of the data set then if you want to correct it.
And people near the equator will have a much greater sine wave than if you're up near the northern Canada.
Now, the majority of what you're seeing is rotation of the
That's
Earth
true.
around,
You're right.
around the
You're right.
sun. So the contribution from the Earth rotation is fairly
It's
small
fairly
compared
small,
to that.
right.
Yeah.
Okay.
Anyway, just one more question. I had a very quick look at the description of the antenna. Is this just one PDF file? Because I couldn't find any dimensions in there.
Oh, the first one lists everything. I mean, it's a step-by-step build and with the final dimensions. Look at the first PDF.
Yep.
Okay. It shows you literally every dimension here and spacing, size. I don't have it.
Maybe must be.
How long is it? How long is that pole?
It all fits on a 3-foot long piece of dowel. It's 0.75 meters, 3/4 meter length.
Okay. Pretty
So
light.
156-inch diameter reflector. So it's something that's easy to carry.
A further step, much more complicated, but direction that someone could move into is the hardware is so simple or inexpensive, let's say, making an array, starting with 2 of these, doing some interferometry, and then expanding it, maybe getting 10 of them. Array technology is fine and could be a future direction.
I'll let you work on that for me, Sam.
We are
Especially
with
the 10.
2,000 elements.
Yeah.
That's the direction that is moving.
So the difficulty that you will run into that is doing the correlation between the antennas. You need to have a multiple coherent input SDR or do some tricks. I think that would be the tricky part, doing the multiple correlations.
Software would do it.
Okay.
I think it's a great bit of work, guys, and I think you're really to be commended. I
Well,
think you've
thanks.
got some super results, and the presentation and the detail that you've gone into it is absolutely terrific.
Yeah, I don't have a
commend you
life.
both.
I do
You've
this
done
all
well
day
done.
long.
I'm looking forward to retirement so I can spend more time on stuff like this. And the kids are out of the house and I'm retired.
I have
Okay.
I have a question. Maybe I missed the answer to this already, but how do you plan to market or distribute these things?
You build
Is there
it
a
yourself.
plan?
Build it yourself.
Ah,
Helen, do a Google or Bing search on H-line 3D, and it brings up all kinds of files. I mean, there's several hundred slides in that. So this is like the intent is for a student, high school, undergrad, college student to learn radio astronomy.
And Alex has certainly been busy this week. I mean, you've gotten a lot of coverage, even getting onto the RTL SDR blog with this project. And you've been in touch with the Rainier developer, who apparently is very excited about the fact that his software is being used for amateur radio astronomy. So I think we may hear more from him.
I was very pleased in his response. He's in Japan and he speaks Japanese. In fact, he's talking about converting the GitHub information into Japanese. So that may have an interesting progression.
Yeah. And I'm actually, one of the features I'd like to add in a soonish release would be supporting multiple languages, which Java gives you some flexibility there. So it'd be great to use string resources so you can switch languages based on your locale, which I think would make this very useful for people who don't speak English.
All right. Any more questions for Alex or Jameson? Great work, guys. And want to put any of the links to those on the website, let me know, and we'll get those hooked up and get you some more publicity. And speaking of languages, if you guys haven't noticed on YouTube, we have been translating some of the popular videos into Spanish, French, and German. Mostly Spanish. I didn't realize how many Spanish radio astronomer people there are, but that's been significant hits on the Spanish side. We'll keep doing that. They don't have Japanese language. They have Japanese text, but the ones we've got here will actually dub your mouth, but they don't have that in Japanese. They just have that in French, German, and English, and Spanish, but they will shift it to Japanese or Chinese or various other things in the text side. We'll try that if we need to. That's the new editor I've got. We'll be able to do that. Okay. And Sandra, now we have you on. How's your 2000 antenna system working?
We're getting it all designed and getting the funding lined up. And what's a wonderful contribution is from Eric Schmidt. Schmidt Futures is giving us tremendous help with funding. We, of course, had put in a National Science Foundation proposal. This is about $150 million array with tremendous resolution, second of arc resolution, and micro JSE sensitivity. And there's been large projects in radio astronomy which just languish. They go on for years because they cost too much. But I think this one's actually going to happen. We're trying to get the land secured. It's over in Nevada near Ely, Nevada. And there are 4.5 meter paraboloids, which have been prototypes that have been made. I've mostly worked on the low noise amplifier, which has 11 Kelvin noise temperature. That's the average from 700 megahertz to 2000 megahertz. There's a tremendous fiber optic connection link. These 2000 antennas are in a 19 kilometer diameter area. So you can imagine they're on the order of 100 meters apart. And there's miles and miles of fiber optic connection. The correlator is something that is being built. Just takes advantage of all the advances in digital processing that are occurring. With 2000 antennas, you have to correlate them in pairs. So that means you got 4 million correlators that are needed. That's all doable within budget, which $150 million, I don't know, maybe 20 million is in processing. It's something that we hope to have running. Let's see, land permits and so forth should be available by 2026. And we plan to have first data by about 2028. Of course, there is a 100 element version of this at Owens Valley Radio Observatory. It's been in operation for a year or two. Some of the same low noise amplifiers, and it's also used as 5 meter dishes. So things are coming along here. I think this will be a great advance in radio astronomy. Glad to answer any questions anybody might have.
What an astronomical undertaking.
Yeah.
Thanks, Sander, and it's an honor to have you here with us. And let's go to another guy who's used your LNAs. That's a Wolfgang.
Yeah. Actually, I can pick up a bit on that subject because there are certain plans to build a small array using almost the same technology, or essentially the same technology as the DSA 2000. There will be a couple of antennas in East Germany and 2 more, at least in the very beginning, one of which will be actually at our site. We are looking into building one of the 5-meter dishes, same type as one of the prototypes that is also going to the DSA 2000 people. That's in very early stages for the eastern part of the multi-elements. We're looking for sites very similar to what the DSA 2000 people are doing. Of course, it's a much smaller scale. It will be something like 10 antennas.
East Germany, did you say?
Yep. It will be in the eastern part of Germany. And we are presently discussing that. We're doing some site surveys for looking for the RFI situation. And the idea is, if everything goes well, there are a few antennas being built which will be shipped to the US as one of the prototypes for the DSA 2000.
Is this MidX doing this?
Yep, that's the MTEX antenna. MTEX. And there are plans that the University of Bonn and Cologne are purchasing one of these antennas and put it on our site. And there will be another at a observatory also in the eastern part of Germany. Timing is yet unclear. We have to see how it all works out. But that's the present plan at the moment. It's not a done deal yet, but we are working on it. Okay, other than that, I don't think I have any news for this week. We're continuing our FRB observations on a routine basis. And next time when Vanessa is again, she may be able to tell a bit about our small interferometer setup, how we are progressing there, but I'll leave that for her.
All right. Any questions for Wolfgang?
No, but let me add a 30-second comment on the H-Line 3D project in that there is no dependency between the hardware and the software. If you can use the software with a scope in a box, you could use the antenna for GNU Radio, Linux stuff. So if you have some IF average files and you want to process them, download the software and try them.
All right, great. Okay, let's get to Dimitri.
Glad to see you. Yeah, glad to see you all. I have on the staff presentation now. I'm continuing observation in 6.7 gigahertz waves. Unfortunately, Cepheus A is appear too convenient time. It's too early in Moscow. I'm planning for next month or two to catch some other sources. 6.7 gigahertz may be in southern hemisphere. To expect some results we'll present later. Glad to see you here, you all. And we just connected to listen to others. Thanks, Rich.
Okay. All right. Thanks, Dimitri. Let's get to Edward.
Hello. Yes. I don't really have anything to present, just a small comment on something I've been working on recently. By the way, can you hear me?
Yeah, you're good.
Great. Okay. So yeah, over the past 1.5 weeks or so, the weather was kind of unusually warm and very humid. So not great for my usual work on water mazes at 22 gigahertz. So I decided to have a look at the other side of the radio spectrum and went down in frequency by about a factor 1000 to 22 megahertz, because my dad and I wanted to try if we could pick up the Jupiter signals. We had never done this before. It's a fun little exploration. So we made a simple dipole antenna, hung it up in the backyard about 4 meters above the ground. And yeah, so far I've only been picking up tremendous amounts of RFI. yeah, this project has turned out to be a little bit more complicated than I hoped for, but maybe if any of you have experience with detecting Jupiter, I would like to know.
Well, I think we got a large group, in the Radio Jove group that does that, but I think it's intermittent. I don't think it's continuous. It'd be very hard to, you have to watch it for a long time and pick up the intermittent stuff. But
Yeah, so far I've just let my, essentially been collecting data every night, especially when there's a prediction of a burst. But so far, I think I'm just running into problems with like too much RFI. It's just too polluted to really see anything.
yeah, if you download the Radio Jupiter Pro from the Radio Sky website, it'll give you a prediction of when the activity happens that you can see on Jupiter. So at least you'll be able to sit there and look at it and say, okay, I'm getting something and it's predicting that I should be getting something. So you can maybe help differentiate that from some of your RFI issues.
Okay, thanks. Yeah. I already also found like an ephemeris, some predictions on the prediction table on the Radio Jove website. So I already have something, but that will be probably another additional useful resource. We'll see.
Yeah. And
if
isn't there and just for the whole crowd here, isn't there supposed to be, the moon's supposed to occult Jupiter? And if that's something that we could potentially observe, anybody? That's supposed to be this month or something, or close. Nope. Anyway, I saw that somewhere. So you might look at that and see if that's going to happen this month. And I think obviously visually, it'd probably be easy to see, but Jupiter might actually be able, if it's actually active radio wise during the occultation, we might be able to pick up the signal drop, which would be very cool to see. Okay. Thanks, Edward.
Okay.
Let's see. Who else we got on the, Peter East?
Yeah, not a lot to report. The weather's not been good lately. October is my best time for doing pulsar work because I can do that at night time. But it's just not been possible so far. So measurement-wise, I haven't done a lot. Yeah, the other problem I've got at the moment is that my webpage has been archived because I've been hit by a denial of service actor of, I don't know where he's from, but for 3 days he pounded my site. So my ISP has shut it down and I'm still in negotiations trying to get it back up again. And I do need that. So that's just my problem. So astronomy wise, not a lot of progress.
Does that mean that you're so advanced in radio astronomy that they're trying to keep you from sending your data out?
I don't know. There are these bots that regularly go through sites. I've had ChatGPT and the Google AI download my sites several times, which kind of upsets my ISP. And this is the second time recently that he's archived it. Before he put it back again very quickly when I showed him the log of the activity on my site. I point out that it's mainly used by amateurs and the hit rate is usually relatively low, but once it gets hit by these denial of service actors, they just keep going for hours. So I just don't know what to do about it. They just have to live with it, I suppose. I don't know if anybody else has got websites that have been hit by either AI bots or these denial of service actors. So, no.
Yeah, there's not much you could do on your side. It's the ISP has to figure that out.
Yeah.
Okay. Any questions for Peter? All right. Thanks.
Yeah.
Jason.
Yeah. Hi, everybody. It's been a few weeks since I've been on, unfortunately. So I got a few quick announcements, and then I do have a presentation. About 3 weeks ago, I got my first tattoo, and it's my initial detection of the hydrogen spectrum of M33, along with Jameson video call sign, because I actually got it less than a week after he passed. So I thought, since he was such an inspiration to me finishing my initial detection project, I'd honor him with that. So yeah, that's something. Another really interesting bit of news from me is, back in July, I applied to a few positions with NRAO, both at Green Bank and at the VLA. And I've been through 2 interviews for the VLA position, and they're paying to fly me out for a site visit on the 28th of this month. So things are looking pretty good. I may be actually doing radio astronomy professionally. So that's pretty exciting, actually.
Might have to kick you out of this group then, I guess, right?
Yeah. I don't know. My background is electrical engineering, so I'd be supporting from the instrumentation side probably. But if nothing else, it'll be really cool to go out there and see that in person. I actually had this prepared almost a month ago, but like I said, I've been circumstances have prevented me from attending for the past several weeks. And I wanted to go through a quick presentation on my tutorial guide that has actually been vetted now and published on the Sarah site, along with my templates and tutorials on how to use the templates themselves. And also, just real quick, Rich, I was wanting to talk to you at some point about doing a Zoom recording of actually a live demo of how I actually do my data processing, so that we can make a tutorial for that.
Not a problem. Just let me know when you're available and we'll set it up.
Cool. All right. So I'm just going to get started. I'm going to go ahead and share my screen here. Wait a minute. Did that come up? There we go. All right. I'm going to share my screen here, and then I will bring up the presentation. Okay, here we go. And there's quite a bit of slides here. I may be a little bit brief on some of them, just to not hog all the time, but wait a minute. Okay, here we go. Like I said, this is intended to be a tutorial, a detailed tutorial on my methods, both for detecting with the small backyard setup using drift scanning, and then also detecting galaxies using the 20-meter scope through Skynet. So I did a brief introduction of the hydrogen line, just because I kind of wanted to make this suitable for pretty much a wide variety of audiences. So I went ahead and it included some preliminary stuff just to explain the hydrogen line itself, what it is. There's pictures of me and my girlfriend at the Eastern Conference this August in front of Ewan's actual horn. So put that in there. And then I've got a copy of Ort's original structural map made from the hydrogen line. It was interesting, as I was reading the history on this, Ort pretty much willed that into existence. He was so adamant that they were going to be able to detect that, even though a lot of experts thought it was theoretically impossible to detect. But he's like, we have to, because it's such a useful tool. And fortunately, he was right. But the interesting thing is, when you're observing galaxies outside the Milky Way, you're seeing a simultaneous red and blue shift because of the spinning of the disk. And the effect is exaggerated the more edge on our perspective is. If we're seeing it directly flat, then there's no redshift, because the motion is entirely tangential, which is also the reason why we see in Ort's map, you see those blind spots. A lot of people think that's from the dust obscuring, but it's not. It's a problem of geometry. The radial velocity is almost zero in those low angles from our perspective. And so, because the motion is almost entirely tangential, so there's no red shift or blue shift.
information to gather. So you get a lot of signal, but you don't get any spatial information. So anyway, here's an example from actual published spectra that I went ahead and scaled so that they matched in their horizontal scale, so that you could compare orientation to width of the blue and red shift. And so you can see M31 is very edge on, so it's very wide. M33 is kind of halfway slanted, so it's a mid-range spread. M101 is getting closer to face on, and so it's a narrow spread. And then M74 is almost entirely face on, so you get almost a single peak for that. Okay, so drift scanning with a small dish. I started with one that was around 3 meters. And then when I got back from the Eastern Conference, I rebuilt from lessons learned and rebuilt a new one that was lighter and a little bit smaller in 2.5 meters. And I still found I got good results with M31 and M33 using the 2.5 meter dish. And it was a lot more portable and manageable, which my intention is to bring it to the conference next year and actually demo it live. So planning your observations. So first thing you want to do is gather information on your target galaxy from credible sources. So you want to get the coordinates, you want to get the reference profile so that you can compare your own data to something that's believable. And then you want to get the average radial velocity so you know what center frequency to set your receiver at, because a lot of these galaxies are moving fast enough that they're well outside of the range of the Milky Way signal. They're shifted way up or down hundreds of kilometers per second. Then the next thing you want to do is look up the VLSR correction so that you know where you're looking. And a good site that I was using another site, but I found that it was interrupted and it was no longer available. But then I found, Green Bank has their own. And the Green Bank calculating site is based on their coordinates. But the thing is, the contribution to the VLSR correction from the rotation of the Earth is only plus or minus 0.5 kilometer a second. So it's a very small part of the whole. And most of it is from the rotation of the Earth around the sun, which is on the order of 30 kilometers a second, plus or minus. So this is good enough, and you don't have to correct it for your time or your geolocation, and you can still get within 0.5 kilometer a second. Because like I said, the contribution from the rotation of the Earth is around 0.5 kilometer a second or less. So the next thing you do is what I did is I used Stellarium, the phone app, actually, to identify the start and stop times for my transit, for my drift scan transit. And so what I would do is I would zoom my window in until the field of view was the width of the half power beam width of my antenna, which I measured using a drift scan of the sun. And then I would just increment my clock on the date that I wanted to plan my observation and find when it entered and exited the field of view. And then I've got my main transit start and stop times. And then I would write that down along with the VLSR correction, the AS-L for my location, all the things I needed to set up my observation. And then what I would do is I would find the duration of the main transit, and then I would take half before and half after as pre and post transit reference scans so that I could calibrate against background near the object to try to eliminate a lot of the Milky Way signal interference. And so to figure out what the center frequency that you want to set your observations to, you basically use the so this is not corrected for special relativity, but at the velocities we're talking about, it's good enough. And so it's an approximation, but it works very well. And so you plug in the velocity of the object, the average velocity of the galaxy you're wanting to look for, and you calculate what your center frequency should be. And I didn't worry about trying to correct this for VLSR because plus or minus 30 kilometers a second wasn't going to change it a whole lot. And so I correct for that in post-processing. So then the next thing after you gather all your observation plan data, then you set up your actual observations. So you set your dish to the as L. And again, this is done using paving stones and plywood and tie downs. People who have a nicer mount could have a more high tech thing, but this was actually achievable with a very low tech system. Setting the center frequency of the AirSpy SDR Sharp software to the center frequency that you chose in your observation plan. And then I recommend using the following settings for IF averaging. So I used a FFT resolution of 128. The reason why I went down so low is because in this case, you're drift scanning, you're trying to get as most bang for your buck out of the limited amount of time that you have on target. And this was a trade-off between frequency resolution, which translates to velocity resolution. And when you're in this case, I got this from JJ Mantois' paper where and he was using a similar FFT resolution, because if you get a higher resolution than that, you're throwing away you're gathering way too much data, and you don't need that much velocity resolution to get the basic spectrum, especially at the low levels that we're doing. Anyway, and then with my setup, using a dynamic averaging count of 7.6 mil or so would give me somewhere on the order of 5 to 6 minutes per file. Now, sometimes I've found that there are the things internally in my operating system that are affecting that. So it's not all. Sometimes it has a little bit less data gathering per unit time than it should. But generally speaking, especially if I reboot and level set everything before I start, I get around 4 to 5 minutes per capture with that setting. Okay, then I connect up my SDR, my feed, my LNA, my bandpass filter, and I'm just using the Nolec H1 solver. So it's got the bandpass filter and the LNA all built in, and that's mounted right on the feed. I press play on the SDR and begin recording data. Launch the IF averaging and hit multiple save. Then I make sure that I start. I usually try to start at least 30 minutes before my pre-transit time, so that I allow the system to stabilize and the things to level set before any meaningful data is collected. And then afterwards, I in my data analysis, my first step is to look at all the files that the IF averaging plugin saved and look at their timestamps and correlate them to my pre, main, and post transit times to figure out which files need to go in which bucket. And then I open a copy of my data analysis spreadsheet and start pasting in the data from these various files. And this is something that I would like to talk to you guys, the guy that was doing the software working with Alex. I think this may be something that would be really good to explore as maybe a future kind of spin-off from what you're doing with the Milky Way stuff. Maybe we could talk later about that. So what I'm doing is I'm pasting in the frequency column from the first file and then the amplitude columns from all the others. The frequencies all match, so I only saved the first one. And then I basically have, in the very first column, I convert the frequencies into VLSR corrected velocities, because eventually when I display my data, I do it as corrected velocity on the horizontal scale of the plot. I put in the VLSR correction value into that cell. And then I edit my pre and post cells for each category and put in the correct data from each of the files. And then in the analysis, on the analysis sheet, I'm basically pointing those pre, main, and post averaging columns to point to the sets of data on the raw data sheet to pull in an average, basically. And like I said, I have a more detailed user file I've got this analysis spreadsheet available as a template, and I have a detailed 1 or 2 page Word document that explains how each thing works and how to set it up and how to use it in detail. Okay, so eventually what I do is I do the main versus reference. So I do the main transit over the average of the pre and post transit. And then I take that, and in the next column over, I convert that to dB using 20 log. And then, so Alex was talking about in his stuff with the Milky Way, there's drift that happens. But I find at these extremely small signal levels where you're looking at galaxies outside the Milky Way, the slant or the slope or the non-flatness of the receiver response also comes into play. So I'm not only doing leveling correcting, but I'm actually doing up to possibly usually only about, I usually only need a second order correction. In this case, I'm using a second order correction, parabolic correction to flatten it. And then it'll generate nice plots. And what you see on the top plot is a copy of the reference profile from one of the professional surveys, and then comparing that to my data. And by the way, that data that's shown on the second plot, my actual drift scan data is what I got tattooed on my arm. So now you can notice this large kind of off scale vertical blip here. That is the residual Milky Way signal that's left after comparing to the off target reference, because it still doesn't remove the whole thing. It removes most of it, but there's still some there. And because we're looking at such tiny signals, the Milky Way, the residual Milky Way signal is still pretty large. Okay, so that's my drift scan tutorial. Any questions on that? And I guess I'll stop here for a minute. Should I go ahead and stop here, or do you want me to continue on with the 20 meter explanation?
Go ahead.
Okay, I didn't want to take more than my share of time here. Okay, so after the Eastern Conference, I became very interested in repeating my extragalactic observations at the hydrogen line using the 20 meter dish at Green Bank through the Skynet program. And so I quickly got up and running with that. And after a few trial attempts with M31 and M33 as kind of my test cases, I developed a pretty bulletproof process. So I'm using on-off mode, which basically sets up the scope to do a short amount of time on target and then a short amount of time just off target. And you can set the amount you want the offset to be. I use 1.5 degrees as L offset. I'm not sure I couldn't find anywhere that told me whether it was plus or minus as L. It's just the magnitude of the offset is what I know. And I have emailed one of the people at Green Bank to ask that question because I couldn't find it anywhere exactly how you know which direction it's offsetting. But either way, it's fine for what I'm doing. I open the browser to this site, and then I log into Sarah's account using the username and password that I got from Steve Zekas. And if anyone, this is, by the way, open to anyone who's a Sarah member. And you don't have to be a U.S. citizen. It's open to all Sarah members. That's something that's new recently. So definitely, if you're interested in exploring this, email Steve Zekas because he can get you up and running. So I actually did this from my phone, believe it or not. In fact, I was sitting at a local brew pub having a beer and setting up observations while I was having a beer at a local brew pub. It was absolutely amazing. And then you click the menu on the top left, top right. I don't know my right from my left here. Anyway, and you select radio observing. You'll see a list of observations that have already been completed or are pending. And you scroll down to the bottom of that page and you can add a new observation. Then you can type into the target lookup field and type in a keyword, and it'll actually find from a library the target you want. So you don't have to go looking it up. It'll actually find it for you. And it'll automatically populate the coordinates for you, or you can manually enter them if you wish. For instance, on M31, I actually manually entered coordinates because it was too large to fit the whole thing inside of the beam width of the 20-meter dish. And so I had to do like multiple observations and add them together to get M31. But most of the other ones are small enough. It has a beam width of about 0.75 degrees. Most of the other, or actually all of the other galaxies would fit easily within that beam width. So then, very important, change the observation name to add your initials, and Steve Zikas will make sure that he vets with you what initials exactly to use, because we like to keep track of who's doing the observations on Sarah's dime. And obviously, certain people will have, if we have enough users, different people will have the same initials. So we got to make sure that people are using a unique identifier. In the chart, there's a chart on that page that will show you based on, so you can select a minimum sun separation and a minimum target elevation above horizon setting. And that's completely editable. And then it'll generate a plot that shows you hours from now, your local time, and it'll tell you when it's going to be in range of those settings. And so you can see, okay, is this going to happen immediately? Or is it going to have to wait for 3 hours or 5 hours or 8 hours before it's going to be in position? You can queue up observations and they'll stay in the queue until they're ready or until the scope is available. And it's first come, first serve. If you get your stuff in there and it's not being used and it's in position, it'll just run. So I selected high resolution mode and I set both the center frequency, and I guess there's a ability to do more than one center frequency for your observation. I only used one, so I would set both of them to basically to an approximation of the rest value for the hydrogen line. So I just set it to 1420.4 megahertz. And then I would select path type as on off, which basically tells the scope, do an on target track and then an off target track. And it'll automatically generate it'll use the off target automatically as a calibration reference. I set my duration to 1 second for each. I set my offset values to 1.5 degrees, and I set it to repeat this 10 times. And then I set my integration time also to 1. And save and continue. And I double check to make sure everything was the way I actually wanted it before I submitted it. And then it'll also tell you how many credits you're using of Sarah's account. Sarah purchases so many credits per year. And I wanted to be conscientious and not use more than my fair share, but they've also told me that we've never used all of our time in a year. I would like to see us take that as a challenge to not leave any time left on the table by the end of the year. Anyway, I'd like to try to use as much of it up as possible on useful observations, obviously. Okay, so then you can go to the Skynet Live part of the site and you can see the status. And so you can look at the green bank line in the Skynet Live and you can see you can see your progress of your observation. And it's like a status bar. So this is my M101 observation. And you can see over time, it's increasing until it's finally done. And then it's idle again. And then you go back to the radio observing and you can see your own data archived and ready to look at. And you click on the ID number, and that's actually a hyperlink, and it'll take you to your raw observations. So I can see to the right, the plots are the raw power. And that a lot of times allows you to see like your on off times. But then over to the right is where you actually see the raw spectrum. The reason why you see two different colors, a green and a red, is because the feed on this scope actually has cross-polarized, identical, simultaneous data gathering. And so they're both basically identical receivers, but they're cross-polarized. So you're getting both polarizations at the same time. One of the things you'll notice here is there's this little blip, and that is the residual Milky Way signal. You can see it's right at 1420.4-ish. Where the spectrum of M31 is actually, or M101 is actually over to to the right because it's redshifted. It's actually receding from us because it's about 25 million light years away. So it's far enough that actual Hubble redshift is coming into play. Then the next thing you want to do is click on your calibrated off source spectrum, and that will pull up your data file. You can click on that and you can download it. It's a text file. And then I actually created an analysis spreadsheet that allows me to dump in that data and do some background correction and things like that to flatten the background and scale the plot to what I need. And what I actually did was average both polarizations together to get it, basically get double the noise suppression, because they're basically gathering the signals from hydrogen are randomly polarized anyway. So I found that if I took the cross polarized inputs and just average them together, I get a nice smooth curve, smoother than either one by itself. And then I've also cited my references. I've got the references that I use there's 2 surveys that I actually used to compare my data against. And these are really useful sources for anybody who wants to get into this themselves, because they have very good reference plots that are really accessible and easy to understand. So I guess that's it for my tutorial. I guess I'll open it up for any questions or comments.
Yes, I have a couple of questions to ask you about your dish. It looks to me that it's set up out in front of your garage.
Yeah.
Do you leave it there? How long do you leave it there?
It's portable. It's like a giant umbrella. It folds up. And so I set it up when I'm taking an observation, maybe for a day or 2, and then I put it away, especially if the weather's getting bad, because I don't want to leave it out in the rain. The structural members are made out of plywood, and I did get this version of it somewhat weatherproof. I weatherproofed it so that hopefully it'll last a little better than my first version, which was not weatherproofed, and it started to deteriorate after about a year's worth of use. But yeah, I only leave it out there for maybe a day or 2 at a time at most. But it takes me literally 10 or 15 minutes to set it up. So it's really, the whole purpose of that design was to make it easy to set up and take down. And I can literally take it. I literally have it sitting on my floor right here in my room, folded up. So I can literally carry it up the stairs, and it's nice and portable and light. So
My other question is, I saw some discussion on the Google Sarah thing about a dish being a true parabola. In your opinion, is that something you tried to build, or is that even important for your?
So you want to get the surface as close to a parabola as possible. And there's actually I went through this in my 2 years worth of designing, building, rebuilding, and redesigning this thing. It didn't work very well from the start. It took me a couple years to really get it working well. And part of the problem was that, the closer you get to a true parabola, the better it performs. And there's actually some scholarly work on how your performance as a percentage of ideal performance compares to your RMS surface area error from a true parabola. And it seems to, the breakover point seems to be around 1/15 of a wavelength. If you get much less than that, it starts dropping off and becoming really poor. But above that, it's within 70 to 90% efficient, depending on how smooth it is. So it's definitely a function of the wavelength. So when you're talking about 21 centimeters, where your wavelength is this long, you can be off by about that much, and you're still going to be you're not losing as much performance as you might think. I guess, does that answer your question?
Yeah. Thank you.
Oh, and something I just realized I saw, I'm seeing Jay Wilson down there. I forgot something else that I was going to mention at the beginning before my presentation. Lisa and I unfortunately missed the pre-screening of the Small Town Universe when they played it before the Eastern Conference, because we just didn't get there in time. But I found that there was a local film festival in Indianapolis that was playing it this last weekend. And so I took a bunch of my kids and Lisa and myself, and we went up there and actually saw it. We sat on the front row, and the filmmaker was actually in attendance. We got to do a Q&A with her afterwards. It was amazing. And when we were waiting to go in, she was talking with me, and she said that Jay was actually doing a screening in Colorado at the same time. And he had, geez, the name's escaping me. The main character from the movie, Ellie, was actually there with Jay at that showing. I just thought that was neat. We were watching it at the same time in different places. So
The questions about and averaging. What's the difference between immediate averaging and dynamic? You mentioned this type of averaging. Please comment.
are you asking what's the difference between calibrating to a hot load versus calibrating against like an off target sky?
Not about off-target sky, tuning of your SDR. You mentioned about immediate averaging 1000 times and more longer dynamic averaging. What's the difference between immediate averaging and dynamic averaging in your SDR tunings?
Actually, I'm not actually sure what the difference is there. What I did is I chose it practically for me when I'm using that particular software application. I choose the dynamic calibration to allow it. Basically, I guess it does it in chunks, and it allows, if I choose, say, like 1,000 for my dynamic, then it allows me to go up to larger values in my total integration time. And so I'm not sure if it's actually a difference or if it's just the way the software is handling them in pieces. The way I understand it, it's still just averaging that total number. And it may just be that that it's doing it in pieces, maybe. I'm not 100% sure actually how that works.
Okay, thanks.
Any other questions for Jason? And he does have a nice large article that will be in the journal with a lot of this stuff in it. Stand by for that too. Thanks, Jason. Good work.
All right. Thank you. Yep.
Okay, Dennis.
Okay, thank you. Nothing much to report. Back to basics. Inspector looked at my grounding system. He says, you are well grounded. You are well grounded. I hope that I'm not going to attract all the lightning from this quadrant. Anyway, so onward and upward, I've got my mast ready to go up, but I'm going to put my Wi-Fi antenna directly at the zenith and do some drift scanning and see what I can find. And I really appreciate the presentation so far. This is fabulous. And I wish I were younger and brighter.
Yeah, youth is wasted on the young. I agree. I do have a question on that lightning. You have one of those little lightning, it's almost like a fuse that goes for coming into the house. And does that affect the signal quality at the levels we're talking about?
I don't know. And in fact, I have one I want to install. I got it from MFJ when I bought a plate for wall, a plate to put on the wall for my pass through. And now I've lost that box in my hobby room. But anyway, I did order one of those, and I would put that in and compare and see whether it attenuates much or not. I would think at our frequencies, it might still conduct a signal to ground through that. I don't know. Hope not.
Basically, they're just a spark gap,
Yes.
and they have very low insertion impedance or whatever you would like to call it.
The more expensive ones will be an actual breakdown, like a neon lamp,
Right.
a fancy neon lamp, and that too shouldn't have too much effect on it.
Okay. All right. Thanks, Dennis.
Thank you.
Helen.
Oh, thank you. Yes, I really don't have anything to say. Everything today was pretty much more technical than my understanding, but I am learning something new every day, so I'm grateful for that. And as far as getting anything outside, we've been having terrible winds here. In fact, we lost the roof on two of the sheds out there. I do have my little telescope that I could bring out, but once this wind heads up. So thank you very much.
Okay. Glad to have you, Helen. Thanks.
Uh-huh.
Charles.
Yeah, not too much to report. Do have my dish back up and running with the position readouts replaced and so forth. So doing a little observing hydrogen line, but mostly staying busy with other projects. The weather's been nice this month, so we've been working on painting the deck and so forth. So I'm tasked with that most of the time. Fortunately, the dish can just keep recording on its own. I just change declination once in a while. So that's about it. Still working on, here's the little position readout thing that I'm using. It's a magnetometer and an accelerometer combination that's kind of useful. So far, I can see that it varies a few tenths of a degree periodically. Of course, there's a lot of solar activity and stuff that may be affecting things too. Okay. Yeah, I'll do that. I'll put the maker in the chat. Yeah, that's about it on this end. And I'll try to write up something about how this C position sensor works, how well it seems to play out. So far, it's done better than the previous one I had. Previous one at high elevation angles, being able to read the Earth's magnetic field gets much harder at high angles. So it was having a much bigger error. And this one seems to be much more stable. So the magnetometers and accelerometers must be helping to compensate each other better in their software. Okay, that's about it, Rich.
Okay. Thanks. Bob, N5BRG.
Yeah, I don't have anything new to report here. I'm just enjoying the presentations and information today. Back to you, Rick.
Okay. Thanks. Bob, Alexa.
Yeah, I'm just, I have nothing to report. I'm just listening to all the other presenters and enjoying what they're presenting.
Okay. Thanks. Chet Mitchell.
Okay. Yeah, I don't have anything directly to share. I've just finished building one of those radio telescopes out of a galvanized bucket. It's all together now, and I'm trying to get it commissioned over the next couple of weeks. So I'm hoping I'll have some data to show you guys next month. I'm also working on getting a back end working for the data I've already collected. I'm working on Ezra and then also on the NSF one that was developed in 2015. And I've had lots of good help from Ted, and Ezra is going very well. The other one, not so much, but I'm hoping to be able to get those going and then have something to share next month.
Great. That'll be fun. Thanks. Nathan.
Howdy, folks. It's been a while. We had some straight line winds and a storm here this summer, and it blew some debris into my telescope and ripped the feed out of it. So it was down a little bit, but I got it all prepared and got it back together. And also work has just been doing the work thing. So just give you some updates on what I have been working on. First, hope everybody got to see the comet. Oop, there you go. There you go. That's my picture of the comet with an iPhone 15. Pretty happy with that. It's the third comet I've been able to photograph in my life so far. So the more the merrier. Some updates on the telescope. I've been modifying it. I'm doing some testing now for an equatorial mount. And as you can see, I've been over here working on controls using stepper motors and a 3D printed slew drive, which I was hoping to make it work in an alt-as configuration, but it just wasn't really capable. So I put it into a equatorial mount, and I've been testing that for a while, making some components, trying to make some improvements, and actually starting to collect some data right now. So this is all my temporary setup. Here right now, I have some bearings, some pillow bearings, and I have my slew drive mounted up here on a post, and it works. It's functional. It's not the best. Where was that? Oh, just lost it. Using it though, I have been able to collect some data using Ted's Ezra tracking capability that he's been adding into it. And so here I tracked for about 24 hours, and I was doing 5 degrees. I was changing 5 degrees. So I'd scan for 5 degrees and then move back 5 and just keep doing that little step through. So working through that and also working on integration times, hoping to improve my accuracy for the HI stuff. But then, of course, I want to get this ready as well to start doing some work on masers and some extragalactic sources and everything too. That's my short-term goals for that. But so far, the testing's gone really well. I do have some improvements I need to make. One, I'm changing the mount that'll go on both of these poles. Currently, it's hanging off to the side of this mount, which is good for strength, but it's bad for flexibility and for your range of motion. So I've redesigned it, and I've got a pretty strong mount here. And so it'll be the slew drive on one end and then the pillow bearing on the other end. They'll be mounted on this on my 37 degree, which is about my latitude right here. Second thing I know that I need to do is I need to shorten this beam quite a bit, put my posts closer together and shorten this beam, because it doesn't, you're only going to get about 10, 15 degrees in either direction before you're hitting the antenna. So be working on that here in the next little bit. And I'm also been working on trying to get some positional feedback. Right now, I'm just relying on the steps and the counts for the stepper motor to provide all that, since unless you have very expensive and fancy rotary encoders, you're going to lose that position every time and your program stops or something. Trying to work on a method using these cheap encoders and some cheap microcontrollers to provide some feedback on those. And I think I've got it figured out, but we'll see how it all works here in the near future, hopefully. Couple other things, been doing some kind of outreach projects for radio astronomy in the area. This week, I actually have 2 talks on the amateur radio club that I belong to, the KY4PG Kentucky Colonels. We're going to have our club meeting on this Tuesday, and they've asked me to discuss kind of the basics of radio astronomy and what you do with it, what your capabilities are. So I'm actually putting together another horn antenna out of the insulated foam and an aluminum waveguide. Got to finish putting that together today and then do some demonstrations and a presentation on what we do and some of our capabilities. And then on Friday, I'm going to Western Kentucky University, my alma mater and local university here, and the Hilltopper Astronomy Club there has asked me to do a discussion. I reached out to some of the professors there, and they asked me to come and do a presentation at the HAC talking about the work of amateur radio astronomers here in this area and what they're doing. It turns out he's actually the professor I spoke to. He specializes, if you will, in radio astronomy and dark nebula and dark clouds and stuff. And so he was very keen to get that information out there in front of his students, as he just did a basic presentation on what is radio astronomy. So I'll just be doing a quick little presentation and also a demonstration this Friday for those guys as well. So I've got both of those presentations ready to go, and I'm ready to go talk about some radio astronomy and maybe recruit some new Sarah members if we're lucky. But actually, for me, that's about all I got right now.
Great. Any questions? Excellent outreach work, too. Thank you very much.
Thank you.
Wendy.
On there now. Not much going on here as usual. I did buy one of those solar cooker dishes, but I haven't set it up yet. The ones that Don was talking about. And so I guess after I set that up, I'll start looking at RFI. So that's about it.
Okay, thanks. Don, I think you got a solar cooker, don't you?
Yeah, I'm in the throes of trying to design a Casa-grain feed. We'll see how that goes. There's a lot of information out there, and most of it is hidden from me at this point because my elementary trigonometry is now, I figure, about 70 years old. So I have to refresh myself on tangent of 2 theta and tangent of theta over 2 equivalents, but I'll get there.
Okay, thanks. And Abdusalam? I'm trying to read that. Are you on? You just popped in. Okay. I think that's it for today. Anybody else have any? Miss anybody? All right. And we do have Drake's Lounge Australia on this Friday, Saturday morning from Australia time. But I'll send out a notice for that. And look for your notice for the journal coming in probably on Wednesday or Thursday. Okay. Thanks, everybody.